All right. Now we continue to the next lesson, which is related to the motion of a projectile. Right. Okay. So let's take a look at this picture. So this picture shows a man who wanted to score a point in basketball. Okay. So he need to throw the ball with a projection in order for the ball to inside the gelong here. Okay. Right. So this is actually a motion of a projectile. Okay. So a basketball is shot at a certain angle. So for projectile, you need to have a certain angle. Whether it is steep angle or it is not a steep angle. So you need to define it. Okay. So what parameters should the shooter consider in order for the basketball to pass through the basket? So do you know what parameters should the shooter here need to consider in order for the basketball to pass through the basket? Do you know? Can you suggest some of the parameters? Guys?
The angle of release, I guess.
Other than that?
Time of flight.
And other than that? That is also correct. For example, you need to shoot, right? What is the parameter that you need to consider?
The shot power, the velocity.
Yeah. And also the distance.
Okay.
Yeah. Okay. Right, distance, speed, the basket location. Anything else? No? Yeah. So if no, and also the height of your height and also the height of the basket lah. Okay. All right. So the projectile motion, it can be treated as two rectilinear motion, one in horizontal and one in vertical direction. So projectile is actually can be represented by using two straight line motion, which is rectilinear. Okay. One in the horizontal. So in the horizontal, which is in the x-axis, okay, it experiencing zero acceleration. So in x-axis, whatever it is zero acceleration unless it is mentioned in the questions. Okay. And the other in the vertical direction experiencing constant acceleration. Okay. So if you have a projectile, your horizontal has zero acceleration and your vertical has constant acceleration, which is from the gravity. Okay. Right. So let's take a look at this picture. So for illustration, consider the two balls on the left. Okay, so you have two balls. You have the red balls and you have the yellow ball. And the red ball falls from the rest. So, for example, you drop the red ball, okay? And then the yellow ball, you throw it up. You throw it with a horizontal velocity. You throw it in horizontally, okay? So each picture in this sequence is taken after the same time interval, okay? So you see here, the first ball, second ball, third ball, fourth ball, fifth ball, sixth ball, and seventh ball. So all of the balls here are taken at the same time interval. For example, the first ball it is at 1 second. The second ball it is at the 2 second. The third ball 3 second. The fourth ball it is 4 second, 5 seconds, 6 seconds, 7 seconds, and so on. Okay. Right. So from here you can notice that both balls are subjected to the same downward acceleration. Okay, so you see here, basically what you can see is that at 1 second, both ball has the same y-axis position. Okay, so if it is in 2D lah. So if it is in 3D, it has z coordinate. The z coordinate is the same with respect to the time. Okay, and then towards the 3 second, so the the y coordinate is still the same. Okay, and the fourth second, the y coordinate is still the same. Okay, the position. Okay. Okay, the position is the same. Okay, instead we free fall, and the other one is we give some velocity to throw it out. Okay, but it has the same downward acceleration because the location of the ball is the same in we call it in vertical. Okay, in vertical axis. Okay, right. Also note that the horizontal distance between successive photo of the yellow ball is constant since the velocity of the horizontal direction is constant. All right. So previously, I told you about it has a constant acceleration. Okay, because the what do you call the position of the red and yellow ball is the same vertically. Okay, with respect to time. And also, the location of the ball in x-axis is similar with respect to time. Okay, so it means that at each fixed time interval, 1 second, 2 second, 3 second, 4 second, so the displacement is the same. Okay, the displacement is the same. So it means that in horizontal, the velocity is constant. Okay, because the displacement with respect to time, it doesn't varies. It has the displacement, but it doesn't varies. Okay, so here from this example, you can understand by the definition of the projectile, where in horizontal the velocity is constant. So when the velocity is constant, the acceleration is 0. Okay, but in vertical, the acceleration is constant. All right, so you can take a look from this example. Right? Okay, so kinematic equations, horizontal motion. So for projectile, in order for you to to investigate, to solve the problem of a projectile, you need to know the kinematic equations. Okay, so first we take a look at the horizontal motion. All right, so since the horizontal acceleration is equals to 0 because the velocity is constant, okay, the velocity in horizontal direction remain constant, and the position in x direction can be determined by, so you can find the position of the horizontal by using this equation. X equals, this is the final position, equals to the initial position plus initial velocity multiplied by x, okay, multiplied by the final position. It is not Vox, it's Vox. Okay, multiplied by t. This one, Vox t. Okay, and then you multiply by time. This is actually final position equals to initial position multiplied by velocity multiplied by time. Okay, so Vox is actually this one. Okay, I will correct it. I will make a correction. Vox here equals to this one. Okay, right. So why is Ax equals to 0? Assuming movement through the air. So do you know why actually Ax is equals to 0? Do you know? You don't know? Guys?
Not sure, Doctor.
Okay, so Ax equals to 0 is actually because we neglect the air resistance. Okay, so if we neglect the air resistance, so that's why Ax is equals to 0. And also Ay is constant. Okay, because we neglect the air resistance. All right, next is vertical motion. Okay, so for vertical motion, which is in y-axis, okay, since the positive y-axis is directed towards Ay equals to negative g, which is the gravity, okay, so application of the constant acceleration equation yields, so we can use the constant acceleration equation, which is the kinematic equation, okay. So Vy equals to the final velocity of y equals to the initial velocity minus the gravity multiplied by time. the final position of y equals to the initial position of y plus initial velocity of y multiplied by t minus 1 over 2 multiplied by gravity multiplied by time squared. Okay, and v square y equals to v initiate y minus 2 gravity, the final position minus the initial position. So for any given problem, only 2 of these 3 equations can be used. Do you know why? If you don't know why, I also don't know why. No, this is because the third equation is actually the derivation from the first and 2 equation. Okay, so when you represent t equals to something and t equals to something here, you can get this equation here. Okay, right. So let's take a look at the example. Okay, as usual. Okay. Let's take a look at the example here. Okay, example 11. Right. A sack slides off the ramp. Okay, so this is the sack, this is the ramp, shown in the figure, with a horizontal velocity of 12 meters per second. Okay, so if the height of the ramp is 6 meters from the floor, determine the time needed. They ask you to find the time for the sack to strike the floor and the range R, which is the horizontal distance, okay, where sacks begin to pile up. All right, so in this example, we already have the origin here. The origin is at A, okay? And then we have the initial velocity here. So 12 meters per second is Vx or Vy?
Vx.
Okay. So we have Vx equals to 12 meters per second. So it is actually constant, right? And also we have the Vy, because it is moving. It shows here with a horizontal velocity of 12 meters per second. So we have the initial Vxo, Vyo equals to 0. Okay, because it only moves in horizontal velocity. Okay, and then between point A and point B, okay, of course, it has the acceleration of Ay equals to negative 9.8 meters per second squared, because it is gravity. Okay, so since we have the velocity of B equals to the velocity of A, because for this example, the velocity of A and B is equal. Okay, VA equals to VB. Okay, equals to 12 meters per second. Right? So we need to find the time and also the x coordinate. Okay, so what we can do is we can use the kinematic formula that we learned in the previous slide. Okay, so the first formula is YB, which is Y here. Okay, YB equals to YA plus VA Y TAB, which is the time that we want to find from A to B, plus 1 over 2 AC T squared AB. Okay, so this is the final position of Y, initial position of A, the final position for Y, initial position for Y, plus the initial velocity for Y multiplied by the time of flight, okay, plus 1 over 2 multiplied by acceleration multiplied by time squared. This is the time of flight. So you can substitute the value here. So YB, what is the value of YB? Do you know?
-6, right?
-6. -6 equals to YA
6.
6.
Oh, yeah.
This is the origin.
Oh, so 0 lah.
0. 0 plus BAY. Okay, because you already what do you call because these things, this what do you call this thing, a sag, this sag, it move only for horizontal velocity. It says that with a horizontal velocity only. Okay, so Vy equals to 0 lah. VA ni. Okay, VA is actually Vy not. Mana equals to VAY. Okay, the name, macam name. Okay. Right, so VAY equals to 0. Okay, 0 multiplied by TAB is equal to 0 lah. Okay, so TAB plus 1/2. Acceleration is negative 9.8. And then you have T squared AB. Okay, alright. So when you rearrange back, okay, you will get TAB equals to 1.11 second. Okay, understand? So this is for vertical. Okay, understand how to get this one?
Yes, sir.
Right. So next is horizontal. Horizontal. Okay. Right. So for horizontal, you can refer the equation in the slide. Okay. XB is the final position of X equals to the initial position of X plus VA, the initial velocity of X, VAX, okay, multiplied by TAB, time of flight. Okay. So actually you already get everything right. So you get XB. We want to find XB, right? Which is the range R. XB, the final position of X. Equals to, what is the value of XA here?
0.
Okay, 0 plus VAX equals to
12.
12 multiplied by
1.11.
1.11. So you get the answer of 13.3 meter. So this is 13.3 meter. So the time equals to 1.11 second. So this is the info that you wanted to find in the question. Right. So next we goes to example 12. Right. For this one, for example 12, okay, it says that the chipping machine is designed to eject wood chips at the initial velocity of 7.5 meters per second as shown in the figure. Right. So this is a chipping machine which is used to grind all the trees here. Okay. So this is the velocity here. Okay, the initial velocity of 7.5 meters per second with a degree of 30 degrees. Okay. If the tube is oriented at 30 degrees from the horizontal, so this is the horizontal, 30 degrees from horizontal, determine how high h, okay, this is the height that the chip strike the pile if at instant they land on the pile 6 meters from the tube. Okay. So they ask you, we have a chipping machine. It ejects wood chips, okay, with the velocity of ejection is 7.5 meters per second. And then the chip is collected here. Okay. So the distance between the machine and also the wood chips here is 6 meters. Okay. And the what do you call this is the horizontal distance. And the vertical distance of from the tube to the ground is 2.1 meter. Okay, and they ask you to find the height of the chip at this time. Okay, so how you can find it? So to find it, first and foremost, we need to find the initial velocity of the chipping machine first. Okay, so it is given the initial velocity is like the magnitude of it. Okay, 7.5 meter per second. So we need to construct it in x and y. Okay, so Ox equals to, you know what is Vox equals to?
7.5 cos 30, right?
Yeah, 7.5 cos 30. Okay, we'll get 6.5 meter per second. Okay, next we have Voy equals to 7.5. 7.5 y. This is cos. This is
Science.
sine. Sine 30 equals to 3.75 meter per second, goes upwards because it is positive. Okay. All right. So we can see here is that, sorry. Okay. So according to the definition of the moment that we learned, okay. So the velocity of Vox, okay, equals to Vax because the velocity is same. Initial until it reach A. So the velocity is same, okay, which is equals to 6.5 meter per second. Okay, so this is Vox, Voy. This is Vax. This is Vay. This is the most language lah. But Vay, okay. All right. So we have also the information of Ay equals to negative 9.81 meter per second squared. As usual, we have the gravity. Okay. So first we can construct in horizontal. Horizontal. Okay. Horizontal as usual, the coordinate of A, which is the coordinate of A here, equals to x0. Final coordinate equals to initial coordinate plus initial velocity multiplied by time from O to A. Okay, so we have XA here. What is XA? The location of the horizontal location of the final location of A in horizontal.
Positive 6.
6 equals to 0 plus VO, we already get here 6.5 divided by DOA. Okay, so you will get the answer DOA is to 0.9231 second. Okay, so right now you already get the time of flight. So right now the time is at 0.9231 second. Okay, right. So next is you need to have a vertical motion. Vertical one, okay, because we wanted to find the h. The h is in vertical, okay. Right, so you have YA, the final location of in y-axis, okay, is here. Okay, this is actually the final location. This is YA. Okay, YA equals to Y naught plus V naught Y, this is V naught X. EOA plus 1 over 2 A of Y E squared OA. Okay. So what is YA here?
Okay. 2.1 minus h.
Yes, 2.1 minus h. Okay. And then you will get 0 plus BOY, you already get here, 3.75. UA you already got here, multiplied by 0.9231 plus 1 over 2, negative 9.81, which is the AY, multiplied by 0.9231 squared. Okay, then you will get the answer of 1.38 meter. Right? Okay, so do you have any question for this example?
No, sir.
All right. So if you don't have any questions, we take a look at the final example today. Okay, so the final example of example 13. Right. So the example 13 says that the track for this racing event was designed so that the riders jump off the slope at 30 degrees. Okay, so the slope of the riders is 30 degrees from a height of 1 meter. Okay, so from the origin to the point B, the vertical distance you only get 1 meter here. Okay, so during a race, it was observed that the riders shown in the figure remain in the mid-air for 1.5 seconds. So this is your TOB, TAB, time from A to B. Okay, determine the speed at which, so they ask you to find the speed at which he was traveling off the ramp, the horizontal distance R, he traveled before striking the ground, and the maximum height each he attains. So they ask you to neglect the side of the bike and the rider. So this is actually the track of the racing event. Okay, so you have the slope of 30 degrees, and the racer goes to until it reaches the ground. Okay, so the time is at 1.5 seconds. Okay, right. So they ask you to find the speed where he was traveling off the ramp here. The horizontal distance. What is the horizontal distance here? And also the maximum height. How high? Okay, that he travels when he races. Okay. All right. So as shown in the figure, we already have the origin here. Okay. So between the ends point of the path AB, the three unknowns are the initial speed. We don't know what is the initial speed. We don't know the range R, and we don't know the vertical component of the velocity. All right. So first, we can initiate the vertical motion first. Vertical motion. Okay. So as usual, vertical motion, okay, equals to YB, because we already have YB here, right? So we can start with vertical motion first. Okay. YB equals to YA plus BAY T A to B. So T A to B we already have, plus 1 over 2 AC TAB squared. Okay. So what is a YB? Final value of Y.
-1.
Yes. 1 equals to YA?
0.
0 plus BA Y. TAB we already have, which is 1.5. Okay, plus 1 over 2, negative 9.8. Okay, TAB squared, 1.5 squared. Okay, so you have BAY equals to, let me calculate first, 1 over 2, negative 9.8. 0.4. Okay, you will get VAY equals to 6.683. Okay, this is your VAY, right? And then VAY is actually VA sine 30. Okay, equals to 6.683. So you get VA equals to 13.38 meter per second. All right, so this is the speed, which is the VA. Right? Can you understand this one?
Can, sir.
Right. So next is we have the horizontal motion. Okay, horizontal. Right. So horizontal motion, we wanted to find R, right? So R equals to XB, the position of horizontal when it is at B, equals to XA plus VA multiplied by VAX multiplied by TAB. Okay. XB, we have R here. XB equals to, what is XA? Guys, what is XA? The initial position of the initial horizontal position.
0, sir.
0 plus AX, we don't know, okay. But from the formula, VX equals to VA cos 30, because this is 30 degree. So it is similar to the previous example, okay. VA cos 30 multiplied by 1.5. Yeah. Okay. And then you will get XB equals to 17.4 meter. So this is 17.4 meter. Okay. And then next we wanted to find the edge here, the maximum height. So how we wanted to find it? Okay, to find this maximum height, we can use another equation. Okay, the third equation of the kinematics. Okay, where we have, okay, so to solve this problem, you need to only consider the motion from here, which is the origin, until it reach the maximum height only, until here only. Okay, from A to C only, right? Okay, so we have BCY squared equals to BAY squared, okay? The final velocity equals to the initial velocity of y plus 2AC YC minus YA, okay? So this is one of the formula that you get in your slides, okay? Right. So what is the value of BCY squared? Do you know? What is the velocity? What is the vertical velocity at point C?
0.
0. Why?
Acceleration. Constant velocity, right?
Yeah,
Wait, no, I mean
because,
acceleration.
because it is actually, yeah, because it is like a transition from positive and negative velocity. So that's why at point C it is 0. Okay. All right, so at point A, okay, we have already VAY equals to this one, okay, 6.683 squared plus 2 negative 9.81, and then YC equals to, what is YC? YC equals to H minus 1, and then minus YA equals to 0. Okay. So do you know why H is minus with 1? This is actually YC. It's YA. Okay. So then you will get you rearrange the equation and you get the value of H equals to 3.28 meter.